Good morning to one and all. Welcome to TSAT. This is Priyanka, pursuing degree second year in Government Degree College for Women, Begumpet.
A bright and a pleasant morning to all the viewers. I, Kulsum Ahmed, studying BCom second year, Government Degree College for Women at Begumpet. And our topic is measures of central tendency. Now let's know what are the learning objectives of measures of central tendency. Introduction to measures of central tendency and its usefulness, arithmetic mean, median and mode. Now calculation under different distribution.
Before going into the topic, let's see why we use measures of central tendency in statistics. In business statistics, we use central tendency to know the central value. Why? Because we have a huge large data in statistics. When we have a hump of information in statistics, it's difficult to deal with it. So we use measures of central tendency in statistics to know the central value, and that central value represents the mass of data. It is also known as location of statistics or central data. And in statistics we use measures of central tendency to calculate averages, and it is also known as averages.
Now let's know usefulness of averages. Following are the main uses of averages. Distribution is explained in a prescribed manner, useful for comparative study of distribution, useful for measuring other statistical measures like dispersion, skewness, etc.
So here comes a question, what is an average? So according to Yalu Chow, an average is a typical value which represents all individual values in a series. The professor want to say that one value will represent all the values in a series. So now let's see measures of central tendency. Measures of central tendency provides a convenient way for describing a set of series with one single value, and that one single value will represents the performance of entire series. For example, if someone asks me how many marks I scored in my previous semesters, I'll say I got 96%, but I never say that in Sanskrit I got 95, in Eco 90. What I am doing here, I am representing all my marks with one single value, that is 96%. To make this, we'll use measures of central tendency. It is also known as central value. Why? Because it will represent center of data, and we have different types of averages in measures of central tendency. That is median, mean, median and mode. What are these things, mean, median, mode? These are types of averages. These are classified under two types, mathematical averages and positional averages. Under mathematical averages, we'll take mean, and under positional averages, we'll take median and mode. So now let's deal with the first one, that is mean. So mean is also known as arithmetic mean or arithmetic average. Definition of mean. Mean is a value or it is a number which is obtained by adding up all the values, that is x values, and after adding all the values we have to divide the total with n. Then we'll get the number median. And we have types of median, that is simple median, weighted mean and combined mean.
Now let's see the calculation of arithmetic mean. Its value is obtained by adding together all the values and by dividing the total by number of items. Arithmetic mean may be simple arithmetic mean, weighted arithmetic mean, calculation of arithmetic mean. In direct method, we have three series, that is individual series, discrete series and continuous series.
So now let's see the first series, that is individual series. We'll see the calculation of mean in individual series. The formula for calculating mean in individual series is x bar is equals to sigma x by n. And the steps for calculation is, first we have to add up all the values of x, then we have to obtain it as sigma x. After that we have to divide it with number of observation, that is n, where x represents arithmetic mean and sigma x represents sum of all variables and n represents number of observations. So now let's see a sum in individual series.
Arithmetic mean. This is the table in which direct method in individual series. This is the serial numbers and this is the marks of students. Formula for individual series is x bar is equals to sigma x by n, where sigma x represents sum of total all values, n represents number of values. Now let's see let's calculate this in the formula. 1 plus this is the serial number, so this is n value. So we have to take how many numbers? 1, 2, 3, 4, 5. So this is 5 and this is the frequency x bar. We have to add up this all value, that is 10 plus 20 plus 30 plus 40 plus 50. That will give us x bar is equals to 150. So let us substitute these values in the formula, that is x bar is equal to sigma x by n. Sigma x, here we got the total, that is 150. So our sigma x is 150 divided by n. N is this 5. 150 by 5. So x bar is equal to 30.
That was a calculation of mean in individual series. So now let's go to discrete series. Discrete series. The steps for calculating mean in discrete series are, first we have to multiply the frequencies with the x value and we have to obtain it as sigma fx. After that we have to multiply sigma fx by number of observation, and the formula for calculating mean in discrete series is x bar is equals to sigma fx divided by n, where f represents frequency, sigma fx represents the total value which is obtained, n represents number of observations. So now let's see a problem which deals with discrete series of mean.
Discrete series. Formula for discrete series is x bar is equals to sigma fx by n, where f is the frequency, fx is f into x value, sigma fx is total of fx value, n is total observation. This is the x value, that is 20, 40, 60, 80, 100, and this is the f value, that is frequency 3, 5, 6, 10 and 6. Now fx is nothing but frequency into x value, that will give 20 into 3 is equal to 60, 40 into 5 is equals to 200, 60 into 6 is equals to 3600, 80 into 10 is equals to 800, 100 into 6 is equals to 600. So we have to add up this all value. We will get sigma fx is equals to 5260. Now let us substitute these values in the formula, that is x bar is equals to sigma fx by n. So our sigma fx value is 5260 divided by n. How we are getting this n value? We have to add up all this number frequencies, that is 3 plus 5 plus 6 plus 10 plus 6 is equals to 30. So let us substitute this value in the formula, that is x bar is equal to sigma fx by n. Our sigma fx is 5260 divided by our n is 30. So x bar is equals to 175.3. In this way we have to calculate in discrete series in mean.
That was a problem of mean in discrete series. So now let's see the third one, that is continuous series. The points for calculating mean in continuous series is first we have to obtain the midpoints, and then we have to multiply the midpoints with the respective frequency. Then we have to obtain it as sigma fm. After that we have to multiply sigma fm by n. Here n represents total of frequency, but whereas in individual and discrete series it represents number of observation. So that is an important point we have to remember. So the formula for calculating mean in continuous series is x bar is equals to sigma fm divided by n.
Now let's see the sum. Continuous series. Formula for continuous series is x bar is equals to sigma fm by n, where f is the frequency, m is the midpoint. How to find out midpoint? In the sense, we have to add up two things, that is lower limit plus upper limit divided by 2. How we will get lower limit and upper limit? In the class intervals, they will be mentioning 2 points, that is lower limit and upper limit. This is 0 is lower limit, 500 is upper limit. We have to add up this both divided by 2, so that we will getting the midpoint. N is number of observation. Now class intervals is given as 0 to 500, 500 to 1000, 1000 to 1500, 1500 to 2000, 2000 to 2500, 2500 to 3000. These are the frequencies value 8, 12, 25, 40, 50, 30. Now to get n value, that is total frequency, we have to add up this all values, that is 8 plus 12 plus 25 plus 40 plus 50 plus 30 is equals to 165. Now we have to find out mid value. Mid value is we have to add up lower limit plus upper limit divided by 2, that is 0 plus 500 by 2, that will give us 250. Same, 500 plus 1000 is equals to 1500 divided by 2 will give us 750. 1000 plus 500, 2500 divided by 2 will give us 1250. 1500 plus 2000, 3500 divided by 2 will give us 1750. 2000 plus 2500, that is 4500 divided by 2 will give us 2250. 2500 plus 3000 will give us 5500 divided by 2, that will give us 2750. Now we have to find out the value of fm. Fm is frequency into mid value, that is this one is frequency, this is mid value. So we have to multiply this both. 250 into 8, 2000, 750 into 12, 9000, 1250 into 25, 31250, 1750 into 40, 70,000. In this way we have to multiply frequency into mid value. So now we have to get up the total of this. 2000 plus 9000 plus 31,250 plus 70,000 plus 1,12,500 plus 82,500. That will give us sigma fm is equals to 30,950. Now let us substitute this value in the formula, that is x bar is equals to sigma fm by n. So our sigma fm is 3,07,250. We have to take this value over here and our n is 165. So x bar is equals to 1862.12. In this way we have to calculate in continuous series.
So that was a sum of mean in continuous series. So now let's go to the other method, that is step deviation method. Actually we use step deviation method to simplify our calculations. So the additional point in step deviation method is we'll take common factor and we'll take a mean which is assumed mean. So the formula for calculating mean in step deviation method is x bar is equals to a plus sigma f dx divided by n into c. This is a formula of step deviation method to calculate mean. So now let's see a sum which deals with the second step deviation method.
Formula for step deviation method is x bar is equals to a plus sigma f dx divided by n into c, where a is the assumed mean, f is the frequency, d is the deviation, dx is deviation into mid value, dx is equals to d by c. D by c. Now let's see in the sum. Class intervals given as 100 to 110, 110 to 120, 120 to 130, 130 to 140, 140 to 150, 150 to 160, 160 to 170, 170 to 180. This is the class intervals. Now this is the frequency, that is 4, 6, 20, 32, 35, 17, 8, 2. Now we have to put the step deviation method, that is d is equals to x minus a. X value is this. Now let us take this 115 as the assumed mean. You can take any number, but I am taking 115 as the assumed mean. As the assumed mean. Now we have to, d is equals to x minus a. We have to subtract this both values, that is 105 minus 10 will give you 115 minus 110 will give us minus 10. 115 minus 115 is equal to 0. 115 minus 125, 10. 135. In this way we have to subtract this. Now d divided by c. C is the common factor. How will get common factor? In the sense, in class intervals they will be giving these two numbers, that is 100, 110. What is the difference between these two? That will be 10. That is the difference is 10. That will be taken as the common factor, d by c. So we have to divide this both. D is this value and d by c is this value. 10 divided by minus 10 is minus 1. 10 by 10 is 1. In this way we have to do d by c. Now fd, we have to multiply frequency into deviation, that is 4 into minus 1 minus 4, 6 into 0 6, 20 into 1 20, 30 into 2 64, and this is the mid value formula. Now let us substitute this all values in the formula, that is x bar is equal to a plus sigma f d divided by n into c. A is the assumed mean, that is 115. This is the assumed mean plus sigma f d. F d is 299. We have to add up this all values to get f d, sigma f d. Add up this minus 4 plus 20 plus 64 plus 99 plus 68 plus 40 plus 12 into c. C is nothing but the common factor. As I already told you all that difference between these two, lower limit and upper limit. 100 minus 110 will give us 10. That is the common factor. So that will become 115 plus 229 divided by 112 is equals to 115 plus 24.50 is equals to 189.5. In this way we have to calculate in step deviation method.
So now let's see the second mean, that is combined mean. When we will use combined mean, like when we have two or more groups of arithmetic mean, then we will use combined mean to combine both the means. The formula for calculating combined mean is x bar 1 2 is equals to n1 into x bar 1 plus n1 into x bar 2 divided by n1 plus n2. We will take this formula when there are two means. If there are 3, we will take x bar 1 2 3 is equals to n1 into x bar 1 plus n2 into x bar 2 plus n3 into x bar 3 divided by n1 plus n2 plus n3. This is the way to calculate combined mean. So now let's see a sum which deals with combined mean.
Means of the two distributors of 100 and 150 are 50 and 40 respectively. Formula for combined mean is x bar 1 2 is equals to n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2. So, x bar 1 and x bar 2 represents means of two series. N1 and N2 represents number of observation of two series. X bar 1 2 is equals to combined mean of the two series. Now let us substitute these values in the formula, that is x bar is equals to n1 x bar 1 plus n1 x bar 2 divided by n1 plus n2. N1 is 100, this one, x bar 1 is 50, n1 into x1. 100 into 50 plus n2 is 150. 150 into x2 is 40. 40 divided by n1 plus n2. 100 plus 150. That will give us x bar 1 2 is equal to 11,000 divided by 250 is equals to 44. In this way, we have to calculate combined mean.
So now let's move to the second one, that is second type of average, that is median. Median, the name itself, it suggests middle value of a distribution, and it is also known as positional average. So why it is named as positional average is because we will find out median by its position. If it is placed in middle, we consider it as median. And according to Professor L.R. Corner, median is that value which will divide the distribution into two groups, and the one part will consist of higher series and the second will consist of lower series. So now we'll take an example to understand the definition, that is we'll take 5 series 1 2 3 4 5. So here 3 will be our median. So the first part 1 2 consists of less values and the other part 4 5 are greater than median. So the professor want to explain these things in the definition. And steps for calculating median in individual series are: first we have to arrange our series in ascending order or descending order. After that we have to apply the formula, that is size of n plus 1 divided by second item. So now let's take an example and calculate median, that is we'll take 3 series, that is 120, 140 and 160. Here now we'll apply the formula in this. The formula is n plus 1 by 2. So there are 3 series, so our n will be 3. So 3 plus 1 divided by 2, that will be 4 divided by 2, that will give 2. So our median is second item, that is 140. In this way we'll calculate median in individual series. So now let's see the calculation of median in discrete series. The steps for calculating median in discrete series are: first we have to arrange the series in ascending order or else in descending order. After arranging the series in ascending and descending order, we have to calculate that, we have to find out cumulative frequency. Once we are done with that, we have to apply the formula, that is n plus 1 divided by 2 item. After that, after applying this formula, just we have to look at the cumulative frequency. In that cumulative frequency, we should consider that value which is equal to n plus 1 divided by second item, or else we have to take the value which is greater than that, but we shouldn't consider the value which is less than that.
Continuous series. Steps involved in continuous series of median is: determine the particular class in which the value of median lies in this series, we have to use n by 2 as the rank of median. After ascertaining the class in which median lies, the following formula is used to determine the exact value of median. M is equals to L1 plus L2 minus L1 divided by F into M minus C, where M is the median. Now let's see in the sum, median in continuous series. Formula is size of n plus 1 by 2 item. N plus 1 by 2 item formula is taken in individual series and in discrete series. In continuous series, we take formula M is equals to L1 plus L2 minus L1 divided by F into M minus C, where L represents lower limit, L2 represents upper limit, F is the frequency, M is the mid value, n by 2, and C is the cumulative frequency presiding the value of median class. Now let's see in the sum. This is cumulative class intervals. This is the frequency 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100. This is the class intervals. Frequency. Frequency is 48, 62, 33, 41, 56, 78, 81, 37, 12, and cumulative frequency, that is 48. How we will get cumulative frequency? We have to add up values. First value we have to take as it is, that is 48. Now we have to add up this both. 48 plus 62, 110. 110 plus 33, 140. 140 plus 41, 184. 184 plus 56, 240. 240 plus 78, 318. 318 plus 81, 399. 399 plus 37, 436. 436 plus 12 will give us 478. Now let us substitute these values in the formula, that is M is equals to n by 2. N by 2 is 448 divided by 2, that is 224. It lies between 50 to 60. 50 to 60. Now M is equals to L1 into L2 minus L1 divided by F into M minus C. Now we have to substitute these values in the formula. M is 50. See, this one is 50 plus 60 minus 50 divided by frequency is 56 into 224. M is this one, 224 minus cumulative frequency is this one. Preceding the cumulative frequency is 164. So we will get the value as 50 plus 0.17 into 40 is equal to 50 plus 7.14 is equal to 57.14. In this way, we have to calculate in continuous series in median.
So that was a calculation of median in 3 series, that is individual series, discrete series and continuous series. So now let's move to the last average, that is mode. Mode is a value which occurs a number of times in the series, that is like it occurs more times when comparing to other values in distribution, and we'll see the calculation of mode in 3 series, individual, discrete and continuous. In individual series, mode is calculated by inspecting, by observing. For example, we'll take 5 series, that is 1, 2, 3, 3, 4. In this 5 series, 3 is most repeated value, that is it is repeated 2 times when comparing to 1, 2 and 4. So we'll consider 3 as a mode. In that way, we'll calculate mode in individual series. In discrete series, like it is not always possible to calculate mode by inspecting. So for that we will calculate, like we have to prepare analyzing table and inspecting table. After preparing this, we will consider the value which is most repeated. So, we'll consider the value which is repeated a number of times, that will be considered as our mode. So, in this way, we'll deal with mode in two series, individual series and discrete series. But whereas in continuous series, like after inspecting the analyzing table and grouping table, we will know the model class, like we will know where the mode lies. So, after that we have to apply a formula, that is m is equals to L plus delta 1 divided by delta 1 plus delta 2 into I, where L represents lower limit, delta 1 is the, like we have to minus the, like we know the where the model class lies, right? So, we have to minus F0 from F1, will get delta 1. In the same way, we have to minus succeeding value from the F, will get delta 2. I is the difference between the class intervals.
Mode in continuous series. Formula for mode in continuous series is mode is equals to L1 plus delta 1 divided by delta 1 plus delta 2 into I, where L represents lower limit, delta 1 is the difference between the frequency and the difference between the preceding model class, and delta 2 is the difference between frequency of the model class and succeeding of the model class. I is the class interval. Now, let us substitute these values in the formula, that is mode is equals to L1 plus delta 1 by delta 1 plus delta 2 into I. So, mode is equals to 200. This is the mode value. How we will come to know mode value? First, we have to check it out in this value, in this frequency, which is the highest value. 27 is the highest value. This will become the table. So, this 200 will be we have to take it as the lower limit, plus delta 1 is we have to subtract this both values, that is model class and this is preceding of the model class, that is 27 minus 18 is equal to 9 divided by delta 1 plus delta 2. Same in case of delta 2, that is 27 minus 20 will give us 7. So, delta 1 is 9 divided by delta 1 plus delta 2. Delta 1 is 9 plus delta 2 is 7 into I. I is 100, class interval. So, we have to 9 divided by 9, 16. 9 divided by 16 into I will give m is equals to 200 plus 6.25 is equals to, that will give 256.25. In this way, we have to calculate mode in continuous series.
Like after doing all these things, even still the mode is ill defined, then we have to use empirical formula, that is mode is equals to 3 median minus 2 mean. Like after doing this grouping analysis, even then the mode is ill defined, then we'll use this empirical formula. This was the calculations of mode in 3 series, that is individual, discrete and continuous series. What we'll do in individual series, we'll just observe, we'll just inspect. By that we will conclude like what is mode. In discrete series, we have to prepare analysis and grouping table. After the preparation of these two tables, we will again inspect and we will conclude mode value. But whereas in continuous series, we will use the formula, that is delta formula, that is m is equals to L1 plus delta 1 divided by delta 1 plus delta 2 into I.
Now let's conclude by saying that we have discussed measures of central tendency. In measures of central tendency, we have seen the types of averages, that is mean, median, Mode. In mean, we have seen individual series, discrete series and continuous series. In these three series, we have seen the steps involved in it and the formulas and how to calculate in this series. Same we have seen in median and mode. In median, we have seen steps, formulas and calculation, whereas in mode also we have seen same, that is steps, formulas and calculation. In this way, we have seen types of averages and how many series are there, that is individual series, discrete series and continuous series. We have calculated this all by using direct method. This is the chapter of measures of central tendency in business statistics. Thank you. Have a nice day.